Limit at infinity, rational functions, and horizontal asymptotes. So limit at infinity, what we are concerned here is finding the limit of a rational function or finding the limit of rational functions as x approaches infinity or negative infinity. So that is what we mean by limit at infinity. Find the indicated limit. Find the limit of 3x squared minus x plus 1 divided by 2x squared minus x plus 1. So since we are looking for the limit as x approaches infinity, and because a rational function, a rational function is of the form f of x over g of x, where f of x and g of x are polynomial functions. So we can apply to this what we are applying to our polynomial functions. So we will pay attention only to the limit of the leading terms. So the leading term here is 3x squared. And so as x approaches infinity, that is equal to infinity. Again, that is the leading term. And the limit of that as x approaches infinity is also infinity. So this one is an indeterminate form. It is not equal to 1. It is not equal to infinity. It is indeterminate. Now pay attention to what I will do. So this function is just equal to this because this factor here is just equal to 1. So I will multiply 1 over x squared to the terms in our numerator and to the terms in our denominator. What did I do here? I just multiplied 1 over x squared to the terms in your numerator and denominator. And look at what happens. X squared divided by x squared is 1. And so we are left here with 3. 3 times 1 is 3. And then x over x squared is 1 over x. And this one is just 1 over x squared. How about our denominator? So x squared divided by x squared is just 2 minus 1 over x and then plus 2 over x squared. So the limit of our rational function f of x over g of x as x approaches infinity is now equal to this limit of, it's a big expression, I know. So you have to be careful and you have to be patient. You have to write this out. 3 minus 1 over x plus 1 over x squared divided by 2 minus 1 over x plus 2 over x squared, the limit of this as x approaches infinity. Okay, so what is the limit of 3 as x approaches infinity? So that's just 3. And the limit of this, as x approaches infinity and your numerators are constants, the limit of that as x approaches infinity is 0. Try dividing 1 by infinity and that will give you 0. So this is just minus 0 plus 0. And this one, the limit of 2, a constant term, as x approaches infinity is just 2. And then the limit of this is just 0 minus 0 plus 0, and this is equal to 3 halves. So the limit of our rational function as x approaches infinity is 3 over 2. Okay, so the titling of our slides is Limit at Infinity and Rational Functions and Horizontal Asymptote. So what this means is this has something to do with the horizontal asymptote. And That is telling you that the horizontal asymptote must be the line y is equal to 3 over 2. Let us verify that from the graph. This is the sketch of the graph of our rational function, and evaluating the limit as x approaches infinity tells us that the limit as x approaches infinity is 3 over 2. So as x approaches infinity, your function will approach a value. Okay? It is increasing. It will approach a value, but it is bounded. So there is like an invisible line here, which is like the boundary telling the graph, hey, you cannot get past this invisible line. And you know what that line is. That line is your horizontal asymptote, as this horizontal asymptote has the equation y is equal to 3 over 2.